ICS4U, this is a lessons on Boolean operators. We've already seen Boolean operators even as early back as grade 10 when we were working with if statements and while loops. Anything with a condition, the condition uses Boolean operators and helps things become either true or false. So in Java, the AND statement is denoted by 2 ampersands. The OR is denoted by 2 pipe characters. Those are the vertical characters. You can get to them by on your keyboard pressing Shift, and it's a character that is close to your Enter key. You'll see it on every North American keyboard. And the not is a bit different. It's a unary operator. It's an exclamation mark, but it can only be used in front of something else that would previously already be able to be evaluated as true or false. And you'll see those that in the examples to come in a moment. Equal sign, just as in Python or other languages, 2 equal signs. I just wanted to take a step back and talk about why we're doing this, and we're formally talking about Boolean operators, even though we've already been using them. So the ICS4U, ICS3U courses, they're university preparation courses. They're computer science. Computer science is the study of algorithms in theory. There is a 4C and 3C course, and those are more, that's computer programming, and that's more like, well, how do I get something to move across a screen? Here's how you do it, and you don't necessarily know the theory behind it. So we talk more about theory in this course. We don't talk about it as much as you would if you did go to university and study the individual algorithms and the science behind it. But this is kind of like a look into that. So let's say that we had 2 variables, x and y, and they were both integers. X was 40 and y was 90. So let's observe the following. We're going to evaluate each of these on either side of the ampersand first. You can see I put them in brackets. They don't necessarily need to be in brackets, but I just put that just to underline the fact that things on either side of the ampersand are individual expressions. So x less than 50, that evaluates to either true or false. In our case, x is 40, so that evaluates to true. What's in yellow is true. X is less than 50. Y greater than 88. Well, y above you can see is 90, so that's also true. The purple condition is also true. So we have true on the left side of the ampersands, true on the right side. So true and true. Well, the whole thing now evaluates to true. Let's look at the next example. X less than 10. Is x less than 10? No, it's not. X is 40, so that evaluates to false. And by now, I think a lot of you have had the engineering course. It's not mandatory for this course though, but you have seen some compound conditions in Python, and you saw that, well, in order for an AND statement to be true, both the left and right sides of it have to evaluate to true. So because the left side evaluates to false, therefore the whole thing evaluates to false. Here we have our next example, x less than 10. Is x less than 10? No, it's not. X is equal to 40, so that's false. However, this is an OR operator. So with an OR operator, as long as either the left or the right side is true, then the whole thing is true. OR will take either or, so it's not as picky. As long as one of the things is true, it's good enough for OR. So maybe your friend who will go out and you go to a fast food place or something, and they'll just eat anything on the menu. So that's OR. And on the other hand is more selective. Okay, so you can think of it that way. Let's look at the y. Y is greater than or equal to 3. Yes, negative 3. Y is greater than negative 3 because y is 90. So because it's true, OR is happy because at least one thing was met, was true, so it will evaluate the whole thing to true. Last example here, and pause if you need to, but here's the last one. X less than 90. Well, x was 40. 40 is less than 90, so that's true. And with the OR statement, as long as one thing is true, we're happy. OR is happy, so therefore the whole thing is true. Just as out of curiosity, why not equal to 90? Y is equal to 90, but OR doesn't care because it already met it was already satisfied with the condition on the left. Now let's look at the truth tables, and this is similar. If you have had the engineering class, this will make, you will have already seen this. It's in a different format. But nevertheless, even if you have no experience with truth tables, it doesn't matter. A truth table is just a table that shows all the possibilities and what they would evaluate with the, so this is for and. So this is a truth table for and. And by definition, all the items in the statement have to be true for the overall statement to be true. So if we have a condition A, I'm just going to summarize it as A. Maybe A is set to be, x less than -3. Maybe B is x greater than or equal to 5. We don't know. But just in general, so again, remember, we're talking about theory. It's computer science. It's a U-level course. So we're talking about a generalization here. And that's something you won't find with a college level course as much. But so A in general, whatever it might be, let's say that A evaluated to false and B evaluated to false. Well, in that case, A and B evaluates to false. If A is false and B is true on the next line, the whole thing ends up being false. Remember, and both things have to be true for and to be satisfied. So that's why we're getting all three falses. Now I'm going to add, it goes on the next page here. What you can do in Google Docs is you can go to Format. Actually, it's something about the paginations. Here we go, View. It's under the View. So under View, uncheck Print Layout, and what you'll see is it gets rid of that big space between the pages. So now we can see that the table all together. And so the last row here, if A is true and B is true, the whole thing is true, and that's the only time it's true. The whole thing's true. Otherwise, it's always false with ampersand, with and. On the other hand, if you look at or, it's always going to be true because remember, or is less selective. The only time when or is not satisfied and not happy is if both A and B are false in the first row. So if A and B are both false in the first row, the result will be false as well. On the other hand, if at least one of A and B are true, the whole thing will be true, and you'll see that all the possibilities are there. Not. Okay, let's look at not. The not operator is really basic. It only acts on one item, so we can only have A. There is no B. So with A, if A is true, well, not A will be evaluated to the opposite. It'll be false. If A is already false, applying a not to it will end up reversing it to true. So not just reverses the result. Here's some more examples here that you can go through, and I will go through those 3 examples. We're just at around 7 minutes, so that's perfect. So example A, we have, and then you're going to get a worksheet with similar questions that you'll have to fill out, and these will be on your upcoming evaluation. Okay, so to approach part A, so you're given this, okay, and is it true? Is it going to evaluate to false? Is this a correct statement? So you're going to evaluate what's in the brackets first. So let's take the first set of brackets. Remember, order of operations, you're going to evaluate what's in the innermost brackets first. So you're going to evaluate not true. Not true is the same as false. So this evaluates to false, what I have highlighted. So it's false or not false. Whenever you have 2 nots, the 2 nots cancel out. So this is the same as false or false. So it evaluates to false, so that's correct. The whole thing evaluates to false. Kind of shown you the first part. So the first part was not true. It was not true. So not true evaluates to false. So I'm just showing that there. What about not false? Not false in the right side of the or statement. Not false evaluates to false. So we have a false or a false, and we get a false as a result. In B, so these are already worked out. We have true or false, anded with false. Now let's just take a step back here. Remember, and is very selective. On either side of the and, it has to evaluate to true. Both of them have to evaluate to true. But because we have a false here on the right side, it doesn't even matter what's on the left side here. We know the whole thing is going to be false. So therefore, it is false. But it's always a good idea. We're still learning this. So let's evaluate what true or false is. This is in brackets. What does true or false evaluate to? This is kind of abstract, right? Because we're dealing, usually we would have conditions that with actual numbers and variables here. but we still have to be able to do this. So true or false. Let's look back to our truth table. So if A is true and B is false, what does OR evaluate to? Remember, OR is not selective. So as long as we have one true, the whole thing evaluates to true. So that's why you're getting true or false equals true. So this part that I'm just highlighting now evaluates to true. So we have true and false. But unfortunately, and is selective. It has to have both sides evaluating to true. So that's why we get a false as a result. So this is just kind of like rough work. I'm going to make that kind of like italicized and maybe 9-point font. Same thing here, italicized, 9-point font. Okay, part C. Not false. Well, a double negative just makes a positive, just like in English class or anything else. So we have a false, and let's work through. This is how the computer would do it. It would do it from the innermost brackets outwards. So we have a false. We apply a not. As soon as we apply the first not to it, it becomes true. But then we have another not, so it flips back to false. So therefore, the result is false. That's the end of the lesson. A little bit confusing because of we just have trues and false, but always look back to the truth table if you need to. And it's not as complicated as it looks. And now you can do the worksheet. See you then.